Okay, in this tutorial we are going to look at how to predict products for synthesis, decomposition, and combustion reactions. If you have not yet read over how to classify reaction types or watch those videos, please make sure to do that because understanding and being able to identify reaction types is a critical piece to being able to do the predicting product side of it. So in the last kind of section, you would have learned that there's 5 classifications of chemical reactions. There's actually hundreds, but since it's just an introductory course, we only do 5 of the hundreds of types that there are. Synthesis, decomposition, single and double displacement, and combustion. So the first step to predicting products, so essentially what we're looking at is a chemical reaction. We're starting with our reactants and we want to figure out what products are going to be produced. So if we look at the first one, I have an element plus an element, and the first thing I want to do is identify what reaction type is whenever you have an element plus an element. And the only reaction type that can be classified as is a synthesis. A synthesis is the only reaction type where you can start just with 2 single elements. That's the only possible thing that can happen, is that those 2 elements join together. There's no other opportunity for them to do anything else. So since I would recognize this as a synthesis reaction, I know in a synthesis that the elements combine together. So what I want to do is put those 2 together. Now you'll want to recall that you do not bring these subscripts into the new compound. All we do is bring the elements in. Okay, so Na and Br come together. Then in order for me to determine what the subscripts are, this is back to Unit 2, we have to look at the charges and balance them. So sodium is from group 1, so it has a +1 charge. Bromine is from group 17, it has a -1 charge. So since those 2 equal out, I do not need any subscripts, and that is it. My product is just NaBr. The only additional step that I would need to do at this point for it to be fully correct is to balance it. So hopefully you've already read through and done your balancing piece. In order for this to balance, I have 2 bromines, so I need to put a 2 here to give me 2 bromines. That gives me 2 sodiums. So I need to balance out my sodiums with a coefficient of 2 there. All right, let's look at the next example. Aluminum and oxygen. Again, since it's just 2 single elements, the only thing that those 2 can do is combine together, and this is what we call a synthesis. So this is going to be another example of a synthesis reaction. So when you're predicting products, that's always your first step, is identify the reaction type based on what reactants you have. So also just a note here, the 2 is on the bromine and the oxygen for the same reason. Both of those are considered diatomics. In your Unit 2 lab, you created an index card where you listed all of the 7 elements that are diatomics, which means by themselves, they have to have a subscript of 2. That rule goes away once they're in a compound. When they're in a compound, you use the charge to figure out a subscript. But by themselves, those 7 elements need a 2. So aluminum and oxygen are going to combine. So in a synthesis, we end up with a single product. So that's going to mean the aluminum and oxygen come together. Again, when you predict products, you do not carry subscripts. Subscripts are on elements or compounds because it's specific to that element or compound. As soon as it changes, then we have to refigure out what those new subscripts are, if any. So when aluminum and oxygen come together, again, this was back from your Unit 2 study. We look up our charges on the periodic table, and then I need a multiplier of a 2 and a multiplier of a 3 in order to get those to cancel out. So then my last step for this would just be to balance them. My oxygens, I need a 2 here. To give me 6 oxygens, a 3 here to give me 6 oxygens, and then aluminum I have 4, so I would need a 4 there. Okay, so that's how we predict products for synthesis reactions. All right, and the next two that we see, both of these are the same, and in both of those instances, I'm starting with a single reactant. There's no plus sign, there's just one reactant. And of the 5 types of reactions, the only type that starts with a single reactant, with meaning there's no plus sign, has to be a decomposition. So decompositions are the only reaction type where you start with one single reactant. All right, so decompositions, as you would have learned in the section about classifying reactions, is whenever you start with 1 and it splits apart into 2. So the Na2O is going to split apart. Again, all we do is split the elements, never carry the subscripts, unless they're in a polyatomic ion, which we haven't seen yet. By themselves, we do not include subscripts ever on elements by themselves. The only case when we would include a subscript on a single element is if it was one of those 7 diatomics, again, that you did in your Unit 2 lab. So oxygen is one of those 7 diatomics, so by itself it is now going to need that 2. So I can go ahead to balance the 2s, or the oxygens, I'm sorry. I need to make 2 over there. I have 4 sodiums and now 4 sodiums. Okay, for the next one, I have iron 3 sulfide, and I've classified as decomposition, so therefore it's going to have to decompose or split apart. Again, biggest thing, make sure you do not carry these subscripts. They are specific to the current compound they are in. When you go to the right side, you have to generate new subscripts. In our case, since they're just splitting apart into the individual elements do not ever have subscripts unless it's one of those 7 diatomics. Neither of those is one of the 7 diatomics, so they're just left alone. So then all I have to do is just make sure that this balances with a 2 there and a 3 there. All right, and then the last group we're going to look at for predicting products, if you look at both of these, they should look very similar. This reaction, whenever you see some type of carbon-hydrogen combination plus oxygen, is known as a combustion reaction. So both of these are combustion reactions. Combustions of the 5, the easiest thing to do for is, in my opinion, is combustions, because combustions, as soon as you've identified them, their products require no calculations, no figuring things out. Anytime it's a combustion, your products are always going to be CO2 and H2O. It's just automatic. As soon as you see that carbon-hydrogen combo on the reactant side, you know that your product has to be carbon dioxide and water. The only thing that's a little tricky with combustions is the balancing piece of it. A little trick that I will tell students when they recognize a reaction that is combustion. My suggestion is to always balance it in alphabetical order. I think it makes it a little bit easier. So if we do that, we can start with the carbons. I have 3 on my reactant side. So I'm going to put a 3 there to make 3 carbons. Next is going to be the hydrogen. I have 2 hydrogens here and 8 hydrogens here. So I'm going to need a coefficient of 4. And then my oxygens. On my left side, I have 2. On my right side, I have 6 plus another 4 here. So I have a total of 10 oxygens on the right side. So that means I'm going to need a coefficient of 5 in order for that to balance. And then for the last predicting products example we'll do, again, I can look at my reactant, see the carbon-hydrogen combo plus oxygen. That tells me it has to be a combustion reaction. Since it's a combustion reaction, I know my products have to be CO2 and H2O. Then I can go ahead and balance it. I'm going to balance it in pen right now. I have 4 carbons, so I'm going to put a coefficient of a 4 here. My hydrogens, I have 10, so I'm going to need 2 times 5 is going to give me my 10. If I add these up, I have 8 oxygens from this one, and then over here I have 5 oxygens, and that is going to give me a total of 13 oxygens. Okay, which is a little bit weird. So again, if you go back here, 2 times what is going to give you 13? Well, technically 6.5 is going to give you the 13 that you need, but from what you should have learned with balancing equations is you can never have a coefficient that's a decimal point. So whenever I will tell students, if you're balancing combustions in this manner and you find that you need that half in order for it to balance, just go through and multiply it by 2 in order to put it into a whole number. So 6.5 times 2 is going to give me 13. But then what you do to one, you have to do to all of them. So then this coefficient gets multiplied by 2, this coefficient gets multiplied by 2, and then this coefficient gets multiplied by 2. Okay, and then that's just, like I said, a little trick to help you with combustion. So that is predicting products, just a few extra examples for synthesis, decomposition, and combustion reactions.